Hello. Hello everyone. I hope we are doing well. I hope we are in. I want us to start our class with immediate effect. And today we are going to be discussing about the volume of solids. We'll be discussing about the volume of solids. And we'll be having a session of approximately 1 hour 30 minutes. 1 hour, then 30 minutes I can give you some work so that you can be able to demystify and dive into activities that we are supposed to be doing. So we will start our class that is in volume of solids, today being date 29th of May 2026. 29th of May 2026, and I want us to start with volume, the volume of solids. So if we are to define volume, volume can simply be defined as the amount of space occupied by matter. Amount of space occupied by matter. So if we are to define volume, we will say that volume is the amount of space that matter occupies. I'm fueling this machine here so that it can give us some justice. Remember, the most important thing is we must ensure that everything is working in place. You're most welcome. So we are saying that volume is the amount of space. Volume is the amount of space occupied by matter. Volume of space is the amount of space occupied by matter. Is the amount of space occupied by matter. So that space that matter occupies is what we simply call the volume. And I want us to start by determining the volume of prisms. So we'll start by finding the volume of prisms. How do we determine the volume of prisms? The volume of prisms. The volume of prisms. So what is a prism? A prism can simply be defined as a solid. It is a solid with a uniform cross section. Is a solid with a uniform cross section. A prism can simply be defined as a solid with a uniform cross section. So if we talk of a prism like a triangular prism, if we can have our example 1, and we have find the volume of the triangular based prism. Find the volume of the triangular based prism of sides 10 centimeters, 7 centimeters, and 13 centimeter, and length is 25 centimeters. Find the volume of a triangular based prism. I think the first idea should be drawing the prism. So this is our prism, and if we draw our prism like that, it is going to be our triangular based prism. I think we can draw this one as broken lines because it is 3-dimensional. You cannot be able to see the other side. So we have been told it is triangular based prism with sides 10 centimeters, 13 centimeters, and 7 centimeters, and a length of 25 centimeters. and a length of 25 centimeters. So if we have such a prism and we have been told to determine the volume, we need to understand, for us to find the volume, the formula is cross-section area. The formula is the cross-section area multiplied by the length. For us to determine the volume of a prism, it is cross-section area multiplied by the length. What is the cross-section? The cross-section area is the area that we can see at the face, which is a triangle. So in this particular case, the volume is equivalent to the cross-section will be the area of our triangle. After we determine the area of our triangle, we are now going to multiply the length. We now multiply the length. And once we do that, we will have determined the volume of the prism. So now, how do we find the area of the triangle? So this being our triangle of sides 13 centimeters, 10 centimeters, 7 centimeters, when we have been given a triangle with three sides are known. When three sides are known, we use what we call the heroine's formula to determine the area. And how do we use the heroine's formula? The first thing we do, we determine, in these sides we call them A, B, and C. We call them A, B, and C. So the first thing we determine, we call it S. And how do we find S? S is equal to, we are going to add everything, A plus B plus C. So that will be 7 plus 10 plus 13. Then we divide by 2. So our S is going to be 7 plus 10 is 17. 17 plus 13 is 30. 17 plus 13. Yes, it's going to be 30. 30 divided by 2 is equal to 15. So when we get our S as 15, for us now to find the area of the triangle, the formula of finding the area of the triangle is the square root of S into bracket S minus A, open another bracket, S minus B, open another bracket, S minus C. I want you to understand that. For us now to get the area, we said that we use the heroine's formula to find the area of a triangle if we have been given all the triangle. We have all the dimensions of the triangle. So what is going to happen in this case, we will now take our area is equal to, we will take our square root sign. Our S is 15, so it will be 15 into bracket, our S in minus, our A is 7, then it will be into bracket 15 minus, our B is 10, then open the bracket, 15 minus 13, and we are done. So what does that simply mean? This means that area is going to be square root of 15 times, remember when we don't have any sign in between, that means it is multiplication. So 15 multiplied by 15 minus 7 is equivalent to 8. Multiplied by 15 minus 10 is equivalent to 5. Multiplied by 15 times minus 13 is equivalent to 2. So when we do that, we are going to get 15 times 8 times 5 times 2. 15 times 8 times 5 times 2 is going to be 1,200. It will be equal to 1,200. So the area of our triangle will be the square root of 1,200. The area of our triangle will be equal to square root of 1,200. And when you get the square root of 1,200, you will get 34.64 centimeters squared. That is the cross section area. So volume, we said, is equal to cross section area times the length. So our volume will be cross section area is 34.64 times our length was 25. From our question, it was 25. So the volume is going to be 34.64 times 25 is equal to 866.03 centimeters cubic. It will not be squared, it is going to be cubic. The reason it is going to be cubic is because we are determining the volume, and the SI unit of volume is equal to cubic. So that is it. So what we are going to do now, that is how we find the volume of a prism, the volume of a prism, the volume of a prism. We have another kind of a prism here, and this prism we have another prism here, a trapezium prism. The question reads, the figure below, this is now example 2. The figure below represents a swimming pool. Calculate. So you can first we can first write the question. The volume of the pool in cubic meters. Part B, the capacity of the pool in liters. The capacity of the pool in liters. So let us draw our pool. Our pool it's the same. That is the shape. So it has 3 meters on the deeper side, 1 meter on the shallow side. Then it has a length of 10 centimeters, and this one is 50 centimeters. 50 centimeters. 50 meters, sorry. 50 meters. So the question is asking, number 1, calculate the volume of the pool in cubic meters. Calculate the volume of the pool in cubic meters. Calculate the volume of the pool in cubic meters. Remember, We say that volume is equals to cross-section area multiplied by the length. So our volume will be, our cross-section area is the area of a trapezium. You can clearly see that this is a trapezium. This is our trapezium. So this trapezium of ours is the cross-section area, the one you can see in your face. And how do we find the area of a trapezium? It is a half multiplied by the sum of the parallel side, which is A plus B, multiplied by height. Then we multiply by the length. So the volume is going to be a half multiplied by A plus B is the sum of these two parallel sides. So it will be 3 plus 1, which is going to be, I think I can just go straight to the point. 3 plus 1 is equal to 4. Then multiplied by height. The height of the trapezium is going to be 50. You can see this one is the trapezium. So the height of the trapezium is going to be 50. Then we will multiply with the length, which is 10. With the length, which is 10. And after we do that, we will get our volume is a half times 4 times 50 times 10. So our volume will be equal to a half times 4 times 50 times 10 will give us 1000 meters cubic. 1000 meters cubic. We have already determined our volume. Our volume is 1000 meters cubic. 1000 meters cubic. After we determine the volume, the next thing we are going to determine is the capacity in liters. The capacity in liters. Part B is asking capacity in liters. Capacity in liters. So check this one out. We have already determined the volume, which is 1000 meters cubic. So we now need to convert meters cubic into liters. So the unit for conversion is 1 meter cubic is equal to 1000 liters. 1 meter cubic is equal to 1000 liters. So what about 1000 meters cubic? What is equal to 1000 meters cubic? So if we cross multiply, we are going to have 1000 multiplied by 1000 over 1. So the capacity is going to be 1 million liters. Or 1 million liters, or you can write this one in standard form. 1, 2, 3, 4, 5, 6. 1.0 times 6 to 1.0 times 10 to power 6 liters. You can write it as standard form. The units are not the same. Hello, let me confirm. Which units? They are the same. The units are the same. The units are the same. Confirm. Confirm clearly. The units are the same. They should all be in meters. They should all be in meters. The units should all be in meters. Yes. The units should all be in meters. All units should be in meters. So, I hope you have understood that one. So, let us now get to volume of a cone. Volume of a cone. So a cone is in shape of this. That is the shape of a cone. When we have this as the shape of the cone, we have the radius. We have perpendicular height is the height from the vertex of the cone to the center of the base. But the slant edge or the slant height is this one. We call it the length. But the perpendicular one is what we call the height. So for us to find the volume of a cone, note this formula with a lot of concern. It is a third pi r squared multiplied by height. Pi r squared is the base. It is a third pi r squared times height. Why pi r squared? Because it is the same as saying volume is equal to a third multiplied by base area times height. Our base area being pi r squared. So for us to determine the base area, it is pi r squared simply because our base is a circle. Have you understood? Yes? Have you understood? Okay. So we can now proceed. Calculate the volume of a cone. Calculate the volume of a cone. Calculate the volume of a cone whose height is 12 centimeters and the length of the slant height. Remember we mentioned the slant height is 13 centimeter. As you take pi is equals to 22 over 7. As you take pi is equal to 22 over 7. As you take pi is equal to 22 over 7. As you take pi is equal to 22 over 7. So, we are going to draw our cone here. We have been told calculate the volume of a cone whose height is 12 centimeter. So this height here is 12 centimeter. We don't have the radius, but we have been given the slant height is 13 centimeters. The slant height is 13 centimeters. And we are supposed to determine the volume of the cone. And for us to determine the volume of the cone, we said the formula of finding the volume of the cone is a third pi r squared h. So what are we going to do in this particular scenario? We must first determine the radius. And you can see clearly that this one here is a right-angled triangle. This one is a right-angled triangle because this one is a perpendicular height. So we can take this triangle with 13 centimeter as the hypotenuse, this one as the height, and we can be able to determine the radius. And what concept are we going to apply here? We will apply the Pythagoras theorem. The Pythagoras theorem, where we say a squared plus b squared is equal to c squared. A and b being the base and the height, while c being the hypotenuse. So what does that mean? If we want to get r squared, it is equal to hypotenuse squared minus the height squared. Hypotenuse squared minus the height squared. So we are going to get our r squared is equal to 25 because 13 squared is 169, 12 squared is 144. So 13 squared, which is 169 minus 144, you will get 25. And for us to get the radius, we will find the square root on both sides and end up getting the radius as 5 centimeters. So our radius here is going to be 5 centimeters. Our radius will be 5 centimeters. And after we get our radius as 5 centimeters, we can now proceed to find the volume, where we said that volume is equals to a third pi r squared h. So the volume is going to be a third times 22 over 7 times our radius is 5 times 5. Why 5 times 5? It is 5 squared, then multiplied by the perpendicular height, which is 12. So our volume will be equal to, if you take your calculator, you will get a third times 22 over 7 times 5 times 5 times 12. You are going to get 314.3 314.3 centimeters cubic. I've written our answer into 4 significant figures. Always ensure you leave your answer to 4 significant figures unless told otherwise. So in the meantime, I would request you to maybe on the comment section tell me whether you have understood or you have not understood, so that we can now proceed to finding the volume of frustums. And after we get the frustum of a cone, we can now proceed to applicational questions and past KCSE questions assessed in these areas, so that you will be prepared. So kindly comment and tell me whether you have understood or not. Okay, let us continue with finding the volume of frustums of cone. That is for cones. So let us do some few questions here. So I'm going to draw a diagram here. This question was done in KCSE. Just a minute. Before we do this, let us do a real question, so that we can be able to probably find the volume of frustum of cones. Aha. Can first draw this diagram. Let's just do it. Can draw that diagram. Our question is reading, the diagram below represents a conical vessel the diagram below represents a conical vessel which stands vertically The vessel contains water to a depth of 30 meters. The radius of the water surface in the vessel is 21 centimeters. Take pi is equals to 22/7. A, calculate the volume of the water in the vessel in centimeters cubic. That question is 2 marks. Calculate the volume of the water in the vessel in centimeters cubic. So the water in the vessel, you can see the water in the vessel has completely filled this cone. You can see we have a cone here. So in simple terms, we are supposed to determine the volume of this cone, this smaller cone here, with a radius of 21 centimeters and with a perpendicular height of 30 centimeters. So for us to find the volume of this water, we determine the volume of that cone, which is equivalent to volume is a third pi r squared times height. So our volume will be a third times 22/7 times our radius is 21 times 21 times 30. And once we do that, we get our volume is a third times 22 over 7 times 21 times 21 times 30. It is going to be 13,860 centimeters cubic. 13,860 centimeters cubic. 13,860 centimeters cubic. The second question is asking, allow me to rub this part. The board is a little bit small, but we will bear as we look up on upgrading the resources. So check out here. The second question tunaambiwa, when a metal sphere is completely submerged in the water, the level of the water in the vessel rises by 6 centimeters. Have you heard that? So kwa mfano hapa juu tuko na kauzi, na haka kauzi kamebeba metal sphere. When this metal sphere imedipiwa ndani, the water level is going to rise. The water level is going to rise. Let me now niondoe hii. So the water level is going to rise by 6 centimeter. So water will now rise from this level, and probably it will come to this level. That is what I want you to understand. And once the water rises to that level, it will rise with how many centimeter? 6 centimeter. So from here to here perpendicularly, it is 6 centimeter. But the new radius we don't have. We don't have the new radius. So what we are going to do, let me use capital R. We don't have the new radius, but at least we have been informed that the water lies to 6 centimeters. So what we are now going to do in this case, the question, calculate. The question is asking, calculate the radius of the new water surface, Roman 1, the radius of the new water surface in the vessel. In the vessel. 2 marks. So we are supposed to find this new radius here. And the concept that we are going to use in this case here, we call it similarity. We call it similarity. So the radius was 21. The height is 30. So we have similarity. And why are we going to use similarity? We will use similarity because when we learned about similarity and enlargement, we say that we can compare equal ratios. We can compare equal ratios, and we can use unknown ratios to determine the known ratios. We can use the unknown ratios to determine the known ratios. So what we are going to do, in this case, we can compare the radius and this small radius. This one is 21. So we can compare radius kubwa over radius ndogo. That is what we are saying in similarity. We have the liberty, provided objects and solids are similar to each other, we can compare their lengths, their ratios. So radius over radius is equal to height over height. That is what we are going to use. It's a concept called similarity. It's a concept we call similarity. So our capital R, our big radius we don't have, it is what we are supposed to find. The new level, the radius of the new level of water. Over our small r we have, which is 21, is equal to our bigger height is the whole of this one, from here to down. So from here to here is 6, then from here to here was 30. So if we add the total, it is going to be 36. So the height kubwa ni 36, over height ndogo ni 30. So with that expression, or with this equation, we can now be able to determine the radius. So we are going to cross multiply. So 30 times R is equal to 21 times 36. So 30 times R is equal to 30R. Then 21 times 36 is equivalent to 756. So we are going to divide by 30 so that we can get our new radius, which is going to be 756 divided by 30 going to be 25.2. So the new radius will be 25.2 centimeters. 25.2 centimeter. And when you do that, you get your 2 marks. Have we understood so far? If you have understood, drop a comment section. Drop something on the comment section and say you have understood. You can as well as share or love, drop your reactions on this live. Have we understood? Have we understood? Are we understanding? I'm waiting for your reply. Communicate to me and tell me whether you are understanding. Yes, confirm whether you are understanding. I want to know whether we are flowing together. So to shut after the radius. We are understanding. Let us continue. The next question. The next question is asking, Roman 2, the volume of the metosphere. The volume of the metosphere in centimeters cubic. The volume of the metosphere in centimeters cubic. The volume of the metosphere in centimeters cubic. So listen, this row, I know if you are doing physics, some of you have applied this row in physics, where we say that if you have a eureka can is in this shape, and we have water to that level, and we want to determine the area of the stone. The area of the stone. Maybe you are dipping a stone in. This water is going to be displaced na itaenda juu. So the water that is going to flow in the measuring cylinder, the volume of this water here is equal to the volume of the stone. Why? Because the amount of water that has been displaced by the stone is directly proportional to the volume of the water in the measuring cylinder. So the same scenario applies in this particular case. The same scenario applies here. So How is this scenario applying? We are going to determine the volume of water that rose. And for us to determine the volume of water that rose, we need first to determine the volume of this bigger cone, which is going to be volume is equal to a third pi r squared h. So we are going to determine the volume of the bigger cone after water rose. Then we subtract the volume of the smaller cone, the one that we determined the first one. Then we subtract so that we can get the volume of the frustum. So the volume is going to be a third times 22/7 times our new radius is 25.2 times 25.2 times the height ya yote ni 36. And once we determine that, we are going to get our volume is a third times 22/7 times 25.2 times 25.2 times 36. We will get our volume is equal to 23,950.08 centimeters cubic. Hiyo ni volume ya hii yote, lakini tunataka volume ya hiyo metal sphere, na tumesema metal sphere ukitaka kujua volume yake ni the same na ile maji displace ikaenda juu. Kwa hivyo tutachukua ile volume hii to subtract ile ya kwanza ambayo ilikuwa I think 13,860, if I am not mistaken. It was 13,860. So we will take, for us to get the volume of this sphere is going to be 23,950.08 minus 13,860, and we are going to get the volume of the sphere is equal to answer minus 13,860. We will get 10,090.08 centimeters cubic. 10,090.08 centimeters cubic. What is not happening? Please ensure you participate and you contribute actively so that I will know that you are in. Master Hajel, communicate with the rest of the team. Tell them to communicate so that we know we are together. Though in YouTube, you feel so lonely because you are communicating to the camera. So, just tell them to participate. I want us to continue So this one is the volume of the sphere. So the volume of the sphere is equal to 10,090.08 centimeters cubic. Last but not the least, the question is asking, find the radius of the sphere. Find the radius of the sphere. Find the radius of the sphere. 3 marks. Find the radius of the sphere. So we have the volume of the sphere. How do we find the volume of the sphere? Volume is equals to 4 over 3 pi r cubic. So for us to find the volume of a sphere, it is 4 over 3 pi r cubic. That is the formula that we use to find the volume of a sphere. So volume of a sphere is 4 over 3 pi r cubic. Don't forget this. It's very, very crucial. Very, very important. 4 over 3 pi r cubic. And now, we already have the volume. So we are going to have 4 over 3 times 22 over 7 times r cubic is equal to, we have the volume, 10,090.08 centimeters cubic. We already have that as our volume. So we are now going to multiply 4 over 3 times 22 over 7. That will be equivalent to 88 over 21 r cubic is equal to 10,090.08. Once we have that, we want to determine the radius. We want to determine the radius. So 88 over 21 r cubic is equal to 10,090.08. We want to be left with r, so we will multiply by 21 over 88 by 21 over 88, and when we simplify, we will get r cubic is equal to 10,090.08 times 21 over 88, and that will give us 2,407.86. This is equal to r cubic. We are now supposed to find the cube root so that we can find r. So we will find the cube root there, and we are going to find the cube root here. So when we find the cube root, you get r is equal to, for you to find the cube root, you click shift, then you click that sign of cube root there, then answer, and you will get your cube root as 13.40. You get your cube root or your r as 13.40. So generally, r is the radius of the sphere, which is going to be 13.40 centimeters. And we are done with that question. It was an applicational question. It was an applicational question. Have we understood? Have we understood? Haya, tumeelewa? Haya, how do we find the volume of a frustum of a cone? That is the shape of the volume of the frustum of a cone with a cut section at the top. So we have the radius, we have a smaller radius, we have a smaller height, and we have now the bigger height, ni hii kubwa yote. So for us to find the volume of a frustum of a cone, it's very easy. Volume is equals to, the volume of a frustum is equal to volume of the big cone or volume of the large cone minus volume of the smaller cone. What does that mean? If you want to determine the volume of the frustum, volume is going to be a third pi r squared h minus a third pi r squared h. That is how we determine the volume of the cone, of the frustum of a cone. That is how we determine the volume of the frustum of a cone. So, with that, let us find out the volume of pyramids. The volume of pyramids. So if we have a pyramid as an example here, that is the height. If we have such a pyramid, the formula is just volume is equal to a third multiplied by base area times height. And height is the perpendicular height, not the slant height. When we were finding the surface area, we used the slant height. But in this case, we are using the perpendicular height from the center to the top. So the formula is that one. So don't forget, the formula of finding the volume of a pyramid is base area. Base area, if the base area is a square, it will be side times side. If the base area is a triangle, you will find the area of the triangle as the base, then multiply by the height. If the base area is a rectangle, you will use length times width, then times the height. That is it. So let us have an example. Find the volume of the following pyramids. Ya kwanza ni triangular base. It's a triangular base pyramid of 5 centimeter, 12 centimeter, 13 centimeters, and the height is 24 centimeters. And the height is 24 centimeters. So that triangle is like this. That pyramid is like this. It's a triangular based pyramid. It looks like that. Let me show you an example. Okay, I am back. There is something I wanted to show you. I went to correct some items here. See this one. This one is a good example. This one is a good example of a triangular based pyramid. You can clearly see that it has a triangular base, and so the perpendicular height is from here, where my hand is, to here. So this is the triangular based pyramid. So that is what we are going to determine. The one that we started with on about the swimming pool, it was like this one. Kama hii ya swimming pool unaona. So it was like that. And we said that for us to determine the volume of such, it was the cross section area, which was the trapezium, multiplied by the length. Multiplied by the length. The cross section area multiplied by the length. And now talking of a frustum, this is the frustum of a pyramid. This one is the frustum of a pyramid. And if you can cut this frustum, so this means there is an incomplete set here. So this one now is the frustum of a pyramid. There is the frustum. This one is the frustum of the pyramid. I hope you have been able to see those. So we are being told it has a base of 5 centimeter, 12 centimeter, 13 centimeter triangular base, and the height from here now to around here at the center is what we are being told is 24 centimeters. So for us to find the volume, we said the volume is a third base area. A third times base area times height. So if you check clearly, our base area is a triangle. Our base area is a triangle of 5 centimeter, 12 centimeter, 13 centimeters. So when we have such a triangle, we are going to determine the area. And for us to determine the area, we say we first find S. We first determine S, which is 12, 5 plus 12 plus 13 divided by 2. And once we do that, we will get S is 5 plus 12 is 17 plus 13 is 20, 30. 30 divided by 2 is 15. Then area is square root of S into bracket S minus A, S minus B, S minus C. So A, B, and C are this dimension. You can say this one is A, B, and C. So our area will be the square root of S is 15 into bracket 15 minus 13, 15 minus 12, and 15 minus 5. And 15 minus 5. Once we do that, we get area is square root of 15 times 15 minus 13 is 2, 15 minus 12 is 3, and 15 minus 5 is 10. So our area will be the square root of 15 times 2 is 30, 30 times 3 is 90, 90 times 10 is equal to 900. So the square root of 900 is going to be 30. So our area will be 30 centimeters squared. After we get our area is 30 centimeters squared, our base area, so our volume is going to be a third times our base area is 30 times our height is 24. Our height is 24. So our volume is going to be, what is a third times 30 times 24? You can simplify by 3 1 by 3 8. 30 times 8 is 240 centimeters cubic. Is 240 centimeters cubic. Is 240 centimeters cubic. It is 240 centimeters cubic. 240 centimeters cubic. So how do we find the volume of the frustum of pyramids? Volume of frustum of pyramids. For us to find the volume of frustum of pyramids, it is the volume of the large pyramid minus the volume of the smaller pyramid. What does that mean? It means for us to get the volume of that frustum of a pyramid, it is a third base area times height minus a third base area times height. That is the formula. So I can see that we've come to the end of our session. I want to close the meeting so that I can send you some work. Let us have a blessed evening. In case it is your first time to be in this channel, ensure you subscribe, turn on the notification bell, like this video, share this video with another student so that they will all be edified. They will get something. And that is all we have for today. We will proceed more with more examples on volume of frustums, of cones and of pyramids. But in the meantime, I want to share some work so that we can be able to rage on what you have understood. Have a blessed evening. Let us meet in our next lesson by the will of God. Have a good night.